right, so our project is Anonymous Studio. The problem that we're solving is essentially organizations in verticals like healthcare and legal and finance. They handle massive amounts of sensitive data every day: patient records, HR files, legal documents, customer exports. Trying to do a manual redaction is slow, inconsistent, and doesn't scale. One missed social security number in a data set that gets shared externally is a compliance violation. We built a platform that seeks to solve this challenge and make this process automatic, auditable, and production ready for enterprise companies. In its current state, our system detects 17 types of PII: names, social security numbers, credit cards, emails, phone numbers, locations, dates, IPs, and more. Once detected, you choose how to handle each type. You can replace it with a placeholder. You can redact it entirely. You can mask it with asterisks or hash it with a SHA-256. The hash operator is particularly useful for compliance. The same PII always produces the same hash, so you can correlate records across data sets without ever exposing the original value. This project started off as a Streamlit proof of concept. It could analyze a single text input and show results. That was it. No batch processing, no persistence, no audit trail, no authorization. It was rebuilt from the ground up using the Taipy framework. It's a Python framework that allows for a lot of the orchestration of the backend processes. So now I'll hand it off to Sakshi, and we'll walk through the text analysis and audit demo.
Hi, my name is Takshi, and I worked on several parts of this project, like related to data handling, pipeline workflow, and improving the user interface. Like I have contributed to uploading sensitive data files like CSV and text files, managing pipelines workflow using cards, exporting audit logs and pipeline histories, and also designing like a more user-friendly page. First, I will demonstrate how user can upload a sensitive data and process it. So here is our sample input, and when we click anonymize, like here, so this feature allows user to upload data that may contain like personal information, and the system will automatically detect and anonymize it using Presidio. Like it will hide our person name, date of birth, email address, phone number, like every private information. Next, I will demonstrate the pipelines. Okay, so like I also worked on pipeline workflow functionality, like where each data set it's represent as a card. This is the pipeline cards we have over here. So if we want to move our card, we can also move it. Like when we click forward, it will go to intake to progress, and then it will go to review, and last it will be done when. And the next I can show the audit logs. Okay, so here here it has the audit logs. This feature is useful for auditing and reporting purpose, especially when organizers need to track like data's what proceed or not. Like when we click on here, it will download it the audit log report. And I have also create one user-friendly page like Analyze Studio page. Like it has a better layout. It has side by side. Okay, yeah. Like it has a side by side comparison of original and proceed data. It also improves visibility, like because of the limitation of Taipy framework, it was difficult to fully integrate this UI into the main application. So like I made decision to revert these changes from the GitHub to maintain system stability. Now Aisha will go through the project.
Hi, my name is Elijah. I contributed to the notification system, the the Open FGA permission, and a little bit debugging of the port configuration. So first I'm going to show the notification system. So the notification has a single function, and here it kind of builds around the notification for sending emails. So in our code, it will read two environmental variables, which is email user and email pass, which is for the password. And if there's any missing details, then it wouldn't throw a reception, except it will give you a printed debug banner. And this will deliver debug choices, and the email auth failures are completely silent at the SMT layer. So the server just closed the connection with no, useful errors. And if both sets are open to the connection, the SMTP Gmails on the ports of 58. It will upgrade the encryption channel, logins, and send a message, and it prints that the email debug emails was sent successfully, and it will take about 10 to 15 seconds for it to reach the user or whenever they click to a different screen. And this is within connection. So on the screen right now, you can see that you could turn on email notifications or in-app notifications. It worked both ways. You will still receive the email notification depending on which user you get or you use. And it's pretty that simple. For the OpenFGA permission, we use what Microsoft usually uses um, I'm sorry, not Microsoft. We use the system Google uses to access their everyday drive files and every calendar event. It's more useful than any other that we found. And so for the Open FGA, how we use it is that it kind of restricts things for other roles. So for example, the developer role, when we enter as a developer, for pipelines and car usages, when we select the car usage and it's try to test one. So when we try to attest a card on the developers page, it will give them a notification that is saying they are unauthorized to use, and then we have to be a higher role than a developer in order to use this function. And then for our debugging of the port configuration, use Taipy's. The Taipy's default port is set to 5000, and in the local dev container, port 5000 is something already occupied. So on the PSS platform, we assign a random port via the port environment, and we give variables in the app, and it must bind to its health check files. And there was no consistent way to override the port. So what I did was I tried to cast init with a try and accept. And that means it's a typo like Tappy ports. So it does not, crash the app. It logs a runtime warning and lets Tappy use its built-in function by default. And without the try and accept, the typo would raise unhandled like value error before the GUI runs. And as you know, it recalls giving me a confusing stack trace, so it doesn't clear the explanation. But after Taipy ports is checked for the first time or second time, um, it'll be able to run it through the same 5,000 port without it getting crashed or sending you an error message saying that there is already a filter port being invalid. So it's easier for the Taipy port to override the 5,000 port without using a different 800 or a 300 port.
All right, so now I'll kind of walk through just a technical deep dive of what we used to build. The first decision we had to make was the framework. Initially, we were going to use Streamlit for the MVP, and after experimenting with that, we discovered that Streamlit blocks the main thread on every callback, which is like fine for a demo, but if it's a huge, 100,000 row CSV, the entire UI freezes until it's done. So a user couldn't navigate, check a status, or do anything. So we decided to move to Taipy, which gives us a reactive GUI, and most importantly, a background job orchestrator in the same library. It has a function called invoke long callback. It's pretty neat. It'll run your heavy, large jobs in the background in a background thread, and fires a callback on the GUI thread only when it finishes. So the user can submit a job and it immediately gets their UI back. That single architectural decision kind of extends the possibilities and moves it away from just a quick demo. The second decision that we made was the storage layer. We knew we'd need support for different environments, and we knew that in-memory having the in-memory option for development and testing would ease our sprints. And then we also wanted something persistent for our demos and a proper database for production. So we designed it with an abstract interface called Storebase, and essentially it defines the full contract. So how you add sessions, query cards, log audit entries, manage appointments. And then there's a modular kind of snap in the backend that you want to run it with. So you can switch between them in as a single environment variable. So it's easy to write a script and select the right one. So this also paid off in a way I really hadn't anticipated. Basically, our entire test suite, there's, I think, over 300 tests, runs against all three backends with 0 code changes. So if a backend breaks, tests can catch it immediately. And then as far as the technical elements of the PII detection, we'll use a library called Microsoft Presidio. It's our detection engine. The neat thing about Presidio is it really isn't a single model. It is a pipeline in itself, and actually brings with it two completely different families of detectors. The first family is pattern-based. So credit card numbers have a Loon checksum, which is essentially a mathematical property that lets you validate whether a number is a plausible card number without any machine learning at all. Social security numbers follow a known format. Email addresses match or regex. IP addresses, IBANs, US passport numbers, medical license numbers. All of those are detected through pattern matching and checksum validation. They work in any environment with no model installed with 0 false negatives on well-formed input. The second family is named entity recognition, detecting that John Doe is a person's name, or that Boston MA is a location, or that Acme Corp is an organization, is not something you could write a regex for. That requires trained language models that has learned from millions of examples. So we use Spacey for this. Spacey's neural models are trained on large corpora and tags. The tag spans in a sentence with entity types. We then bridge that into Presidio's vocabulary. Spacey's per becomes person, org becomes organization, et cetera, et cetera. There's a variety of models. The Encore Web LG has been the one that we have preferred. It's about 560 megabytes and gives the best accuracy for general English text. We also support medium and small variants and a transformer-based model that would be the most accurate. However, it's slow. The system tries each one in the order at startup and uses the first one that it finds. If none are installed, which happens in restricted or offline environments, it falls back to the blank Spacey model. The blank model gives Presidio something to load, but it has no NER capability. Pattern-based detection still works, but person, location, organization gets silently skipped. So we surface that in the UI with a warning banner so users know exactly what they're getting at their startup. On top of that, we added in allow list and deny list support. An allow list is words that should never be flagged if they match a pattern. So if your company name looks like it could be a person's name, you can add it to the allow list. The deny list would be obviously like words that must always be flagged regardless of confidence. Internal employee IDs, anything a trained model would never know anything about. Every deny list match comes back with a confidence score of 1. And every detection comes with a rationale, which recognizer fired, which pattern matched, what the raw confidence score was before context boosting. For a compliance team, being able to say this social security number was flagged because it matched the social security number regex with checks on validation is what makes the output auditable and not just useful. As far as some lessons that I learned during this project, first I would things I would probably do differently would be to define the authorization before writing any of the features. We added in OpenFGA later in the sprints, which means every feature that existed before it had to be audited and like retrofitted for those permission checks. Ideally in an enterprise production environment, it's probably not realistic that you would ship something like that, but I think building around the auth model would have made things easier. Second, I would have like containerized the application from day one. Our supporting services all run in Docker Compose. The main app doesn't. That means that every person that joins the project has to manually install the right Python version, set up a virtual environment, and install the dependencies and configure their environment variables. That friction obviously like can cause delays and confusion. And third, I personally should have broken up some of my commits into the smaller sections, so be smaller pull requests. Some of my large ones, it would make it hard to troubleshoot if you discover that there was a regression and needs to go back. And yeah, I think it was super easy to add MongoDB. We added that mid-project. It required 0 changes to the UI or business logic. We we started to leverage our CI checks more to find like one class, to basically limit a class of bug. Like if it broke something once, then we would write checks to make sure that it didn't keep kind of resurfacing. And the non-blocking architecture is real and it's really cool. It was tested against a 3,000 row CSV that I had my language model write, and it took 4 minutes to process while the UI stayed fully responsive, which is pretty cool.
Okay, so while working on this project, one of the biggest technical challenge I faced was understanding how the front end and back end interact within the Taipy framework. Like unlike traditional web frameworks, Taipy uses dynamic callbacks and state management, which made it difficult at first to understand how user actions like clicking a button or uploading a file or trigger backend processing. Like I had to spend time exploring how functions defined in the UI connect to the logic in the backend, especially files like app.py and definitions.py. And another challenge I faced was when I created a hybrid page to improve the user interface. Like this version was more user friendly and included features like a better layout and side by side comparison of original and proceed text. Like, however, integrating this UI into the main application was like difficult because of the limitation in the Type framework. Like the framework did not fully support the custom behavior that I have implemented in that page. Like to solve this challenge, I tested application step by running it locally and debugging its features individually. Like I also reviewed the existing code base carefully to understand how data flows go through the systems. Like in case of the that hybrid UI that I have made, uh, I I decide to revert the changes in GitHub to avoid breaking the system and to maintain stability. This experience helped me to improve my problem solving skills and understand how to work within the limitations of the framework. Okay, so from this project, I learned uh, lessons like both technically as a part of a team. One of the most important technical skills I developed was understanding how a full stack application works. I learned how to front end, back end, and database are connected and how data flows go through the system from user input to processing and storage. I also gained experience working with new technologies such as Taipy, MongoDB, and Spacey for IPP detection. Like I also learned how uh, if I want to do this project again, I would spend more time in the beginning understanding the system architect and planning the UI integration more carefully. This project was valuable experience and helped me build confidence in working on real world applications.
The challenges that I faced kind of center around a recurring theme, which was thread safety, silent failures, and a little fragile infrastructure. So an example would be the schedule that couldn't call Tipsy notify directly, and it required a design of a queue and flush pattern. So it toasted the deliver safeties on the GUI thread at the next navigation event, and emails were simply decrypted. SMTP failures produce like no visible errors by default. So it was missing credentials, or if a bad password would go through, it would basically do nothing. And then another thing I challenged was for the OpenFGA. when adding it, it added complexity to the project. And when the servers was down or the ENV virus was misconfigured, we had to decide what the app should do, and getting the identity resolution chain, which was the proxy headers going to the local auth and the demo rules fallback. It was consistent across the environment and took multiple iterations. And on top of that, the port 5000 collision in a dev container and the unpredictable PAS ports injections meant that, it started itself wasn't reliable until we added like explicit parsing and a safe interior fallback. Those itself was hard, especially during the debugging phases of our project. It took us a lot longer than we expected, but together we did get it done and figured out. And the lesson learned from that would be um, to visually see the problem instead of beating it with guesswork. um for example, the email debug banner, the author pass logins, and the starter configure summary tables each have like saved the real debugging time, and not because it fixed the bug, but because they made the current state of the system immediately readable. And the second lesson is that the save default have to be, international. I'm sorry, intentional. There was like fail clauses, authorizations, and bypasses modes for local devs that was like both have to be explicit and logged, or developers either give false confidence that permissions aren't enforced, which took me a while with the OpenGFA. And then sometimes I was learn to spend time wondering why all the check passes would without a running FGA stack. That helped me through the FGA when going through the data and the infrastructure. And a good instrumentation and clear communication default turn out to matter more for demo reading than individual features. So those were the challenges and the lessons I learned from this project.
Yeah, and just to kind of round it all out, our CI and just the checks that we've run have been really helpful. We ran CodeQL for code integrity and security checks. We've also been using Dependabot, so we'll get automated alerts when a dependency needs to be updated. Added a issue template, so actually wired where you can, if you open an issue, it will add it to the backlog of the project, of our project board. And these are just for example, here's a workflow. And if we look at our projects board, can see how far we've come. It's kind of crazy from this view to look at it. But yeah, we knocked it out, and that's about it.